Hello everyone. In this video, my objective is to compare an empirical distribution with a normal distribution as a theoretical distribution. For this purpose, I have taken a data of prices of townhouses sold in the Western metropolitan area of Melbourne in 2017. The first step is to find the frequency distribution of prices using histogram in data analysis tool available under data. So let's click on data, then data analysis and pick histogram, click OK. Now you have to provide input range. So I select from A1 and go to the last value which is available in cell A78. I leave the bin range empty so that Excel picks the bin values itself. Finally, under output range, I provide the cell address G1 so that output should be available in cell G1 and onwards. Now, we find that we have got a frequency distribution here, and we will replace the final class more with the maximum value of the prices. So replace that with equal to max and then the array address and finally hit enter. That gives you the maximum value of 1731. Now we have constructed the frequency distribution, and we have to find the class interval, which would be the difference between any of two consecutive values. So if I construct the class interval, that would be equal to the second value minus the first value in bin series. And what I observe is that the class interval is 178.875. Since our objective is to superimpose normal curve on the empirical distribution, therefore we must construct the histogram manually rather than using the cluster bar chart. For this, the first step would be we should include one more value in the sequence under bin by adding the interval 178.875 in the last value 1731. So let's do that. I take the value 1731 and then add the interval 178, and we don't have any value corresponding to that, so let's put there 0. Now I have to generate a series X such that the first and the last values will be included twice, but the rest of the values will appear 3 times in the new series. So let's put X here, and the first value in the bin should appear 2 times, 300, 300. The rest of the values, they should appear 3 times. So let's copy that to the next 3 cells. Then 657, copy that, paste in the next 3 cells, and so on. So we repeat this exercise until we reach the last value. So we see that the last value appears twice in this sequence. Now we also generate a new series Y such that we repeat each of the frequencies twice, but starting value with 0 every time. So let's put 0 first, and then the first frequency, which is 1, 2 times, then again 0 and 7 2 times, 0, 19 twice, and so on. So we have filled all those frequencies here in series Y with first entry as 0, and then first frequency twice, then again 0, 7 twice, 0, 19 twice, and so on until we reach the last value of 1, which is again 0, 1, 1, and then 0. Now we can construct the histogram manually by selecting X and Y series together, and then we click on insert. Under scatter plot, we will pick the lines, and that generates the histogram for us. So let's cut that and paste somewhere here. This is our histogram, which corresponds to the distribution of prices. In the next step, we find the mean and standard deviation of the actual data. Also, one of the important characteristics of any normal distribution is It covers approximately 99% area under the curve within 3 standard deviations from the mean. So let's find these values. First, the mean, standard deviation, mean minus 3 SD, mean plus 3 SD. Mean is computed using the formula average. Likewise, the standard deviation, we would be using sample standard deviation here. And then mean minus the standard deviation, mean minus 3 times the standard deviation. So 3 into standard deviation, and so mean plus 3 times the standard deviation. Because we want to superimpose normal curve, therefore we have to generate a grid first. So let's call the series grid. It starts from 3 standard deviations from the mean, which is 67.18 value, and then we have to write the next value. To find the next value in the grid, I have to add some step in the first value, which is 20th part of standard deviation. So I divide standard deviation with 20, and that is the step size. So let's find the second value in the grid, first value plus the step size, and we fix that with dollar signs and then copy the formula to the rest of the values. Now we have to generate the grid, the sequence, such that the final value becomes 1412.49. So let's look at the final value. It's not 1412, so drag it down until it becomes 1412, and we observe this appears here. So these are all redundant. In the next step, I have to find the density corresponding to these grid points. So I would be using the command equal to norm dot dist with the first value in the grid as x, mean as the actual mean value, and fixing the with the dollar sign. Likewise for standard deviation, and then for cumulative I will use false because I need a probability mass function. So I would use 0 there. That essentially is false, and that gives me a value which is pretty close to 0. So let me change this to a number. Now I copy the formula to the rest of the values, and I have generated a density. Here I have to apply some scaling on these densities. So I generate a factor value. Let me call that f equals to the number of observations n times the bin size, which is essentially the class interval, and I compute that value as total of 77 observations multiplied by the class interval 178, and hence I find the scale factor as 13,773. The reason here is that I have to find total area under the histogram, so I have to scale up the density so that total area remains the same. Now I compute a new series normal, which is equal to density times the factor value, and I have to fix that cell as well, and I copy this to the rest of the values. Now I'm ready to superimpose normal curve to my histogram. So I click on the chart and then click on chart design here, and then click on select data. Now you have to add a series. Series name is normal. Series X values must be the values under the grid. Series Y values must be the values under the series normal here. There. Okay. Now I click OK, and what we observe is a normal curve superimposed on our histogram. So we can contrast the empirical distribution and the theoretical distribution. What we observe is that the empirical distribution does not resemble to normal distribution. It has high peak and is more skewed to the right. Therefore, we can say that the prices of townhouses in 2017, they do not follow normal distribution. They are skewed to the right. Thank you very much for watching my video.